Hi guys! Welcome back to my channel. So we will be discussing for today problem solvings in time study. Now to recap, we are going to discuss a few formulas that you will be needing for the solution to the following problems. So we have the formula for normal time or NT, and this is given by OT multiplied by RF over 100, where OT is your observed time and RF is your rating factor. Now, for the standard time, we have two cases. So, case 1 is given as your normal time multiplied by 1 plus the allowance factor. And for case 2, we have your normal time divided by 1 minus the allowance factor. Now, let's discuss what's the difference between the two cases. So, for the first case, so this is where the allowance is given as a fraction of the normal time, and usually this is stated in the problem as the allowance is added to the normal time. Now, for case 2, so this is when the allowances is given as a fraction of the total workday and usually used when production time is not known. Now, by default, the format of the problem is always under case 1. So, unless stated, so it should be case 2. So, ang default niya, case 1. So, laging ina-add lang yung allowance factor to the normal time. Now, let us proceed with our examples. Now, for example 1, a restaurant conducted a time study for a job assembling ham and cheese sandwiches. There were 10 cycles on the job, and the average time was recorded to be 0.385 minutes. So, we want to determine the standard time of the assembly if the operator is rated at 80% and that the allowance factor is given as 12%. Now, for our solution, so let us write the given information. So, we are given your observed time as 0.385 minutes, and then that the rating factor is given as 80%. And then, lastly, we have the allowance factor at 12%. Now, for your normal time, so again, we will be rewriting the formula where OT is multiplied by your RF divided by 100. So, we always divide the rating factor by 100 if the rating factor is expressed as a percent form. So, this is going to be 0.385 multiplied by 80 over 100, and that should give us an answer of 0.308 minutes. Next is to solve for the standard time. Now, again, the formula requires for case 1, since wala naman binanggit kung ano yung mode of use ng allowance factor natin. So, this will follow case 1 where NT is just multiplied by 1 plus the allowance factor. And plugging in the value, so this will give us your 0.308 multiplied by 1 plus 0.12 or simply times 1.12 since inad lang naman natin siya. And that should give us an answer of 0.345 minutes. Now, let's have another example. So, for example 2, a manufacturing company conducted a time study for 10 cycles of a job. The job has 5 elements, and the total elemental times in minutes for each element and the performance rating factor are given as follows. We want to determine the standard time if the allowance factor is 18%. Now, looking at our given example, we have 5 elements. And again, for us to know the standard time for a particular job, we need to find first the elemental times and then add them all up, and that will give you the standard time of the operation. Now, in this example, stated siya that the operation is consist of 5 elements. So, we are given the sum or the total time or total observed times for each element with their respective rating factors. So clearly, we want to know what is the actual time for each element by dividing your total sum or the sum of your elemental times by 10. So since yung ating cycles daw is composed of 10 or your problem is composed of 10 cycles. So, yung 3.61 is obtained by adding all the observations that is equal to 10. Now, let's proceed to the solution. So, given tayo that your n or the number of cycles is given at 10. And then our allowance factor is given as 18%. And then again, rewriting the following information for all the 5 elements, A to E. Now, the next step, once we have written all the information, is to get the average observed time. Now, again, why do we need to get the average observed time? Since yung time na nakuha natin is from a total of 10 cycles. So, ibig sabihin, your 3.61 for element A should be divided by 10 cycles to get the average observed time. So, that's 3.61 divided by 10 will give us 0.361. Consequently, 4.84 divided by 10 will give us 0.484. Followed by 2.93 will be 0.293. 4.91 will become 0.491. And lastly, 1.78 divided by 10 should give us 0.178. So once we have obtained the average observed time, the next step is for us to get the average normal time. So the average normal time is simply the product of multiplying your rating factor with your average observed time. Now take note that in this particular problem, your rating factor is already expressed in decimal form. So we don't need to divide your rating factor by 100. So, in this case, we'll just multiply your rating factor with your average observed time. So, that will be 1.05 multiplied by 0.361. That will give us an answer of 0.379. 0.9 multiplied by 0.484 will give us an answer of 0.436. 1 times 0.293 is simply 0.293. 1.1 times 0.491 is 0.540, and lastly 0.95 multiplied by 0.178 will give us 0.169. Now, we already completed the average normal time for each element, and again, balikan natin yung concept for getting the standard time. Standard time is simply the total normal time of an elemental operation, and then we add in the allowance factor. Now, getting the sum of all your average normal time for elements A to E will give us an answer of 1.817. So, this is your total normal time, and the next step is for us to get the standard time. Standard time is again by the formula, default formula, since walang naka-indicate kung anong case daw inad yung allowance factor. And this will give us 1.817 multiplied by 1 plus 0.18. And that should give us an answer of 2.144 minutes as your final answer. Now, let us move on to the next and final example for this video tutorial. So, for example 3, a time study was conducted in an operation with 3 elements. Now, each element was observed 4 times, and the following table shows the recorded data. We want to determine the normal time and the standard time for the operation for an allowance factor of 10%. So, additionally, the allowance factor is taken as a fraction of the entire workday. Now, looking at our given problem, so it was clearly stated that your allowance factor will fall under case 2, or the formula that we will be using for the standard time is under case 2, since naka-indicate dito that the allowance factor is taken as a fraction of the entire workday. Now, let us see the given information from the data table. So we have 3 elements A, B, and C. And we have 4 observations each for each element. So for element A, so we have obtained 0.2, 0.3, 0.25, and 0.23 for the observed times. While for element B, we have 0.18, 0.15, 0.17, and 0.16. And lastly, for element C, we have 0.08, 0.05, 0.07, and 0.09. Now, take note that the observation times is given as or in minutes. And then followed by the given rating factor for each element. So we have 1.2, 0.85, and 0.92 for elements A, B, and C respectively. Now let us go to the solution. So we will be writing, or I will be writing the steps for us to compute for problems like this. So for step 1, so we need to get the average observed time per element. Now take note na hindi siya nakatotal this time. So we are given the raw data for the study. So for each element daw, we have taken 4 observations each. Then after we have obtained the average observed time for each element, the next step is to get the normal time for each element and then get the sum. So once we have obtained the average observed time, so we will be multiplying the average observed time by the rating factor for each element to get the normal time. And again, since the operation consists of 3 elements, so we need to get the sum of the normal time of those 3 elements for us to be prepared for the solution of your standard time. And finally, for the third step is to get the standard time for the operation. Now, let's go through the solution. So, for the average observed time for element A, so we have 0.2 plus 0.3 plus 0.25 plus 0.23, and we will be dividing that by the 4 observations taken. So, that should give us an answer of 0.245. That is in minute. And then for element B, so that is 0.2 or 0.18 plus 0.15 plus 0.17, then plus 0.16 divided by the 4 observations taken, and that should give us an answer of 0.165. Then for element C, so that will be 0.08 plus 0.05 plus 0.07 plus 0.09, and again divide it by 4 to represent the number of observations taken, and that is 0.073. So usually we use 3 to 4 decimal places. Okay, so now we are complete with the average observed time. The next step is to get the average normal time for each element. So for the normal time of your element A, so we simply multiply the average observed time of element A by the corresponding rating factor. And that is 0.245 multiplied by 1.2. So that will give us an answer of 0.294. Next is for element B, and that is 0.165 multiplied by 0.85, and that is 0.140. Next is element C, and that is your computed 0.073 times 0.92, and that is 0.067. So, for us to get the standard time, again, we need to get the sum of your normal time. So, that is by adding your 0.294 plus 0.140 plus 0.067, and that should give us an answer of 0.501. Then for your standard time, again, it was stated that the allowance is given as a fraction of the total workday. So we will be using the formula for case 2, which is your summation of your normal time divided by 1 minus the allowance factor. Then plugging in the formula, that's 0.501 divided by 1 minus 0.10, and that should give us an answer of 0.557 minutes. So this concludes the first part of our time study problem solving. So stay tuned for the next video for more computations about time study.